Hello guys, welcome to one of the most important aspects of the studies under matrices. It is very sensitive and we need to be very much prepared to understand this particular section of our studies on matrices. We are studying multiplication of matrices today. And under these studies, we are going to understand scalar multiplication, matrix by matrix multiplication, and creative examples. Now, the introduction to this section is to understand the types of matrix multiplication that we have. The first one is we have scalar multiplication, and it deals with multiplying every element of the matrix by a constant. So you are going to multiply all the entries of the matrix by a constant. We also have matrix by matrix multiplication. That is, under this section 2, we are going to combine two matrices, which is going to be based on dot product rule. And what does the rule says? The dot product rule says that row will multiply column. That is row by column multiplication. Now, let's go to scalar multiplication of matrices. What is it? So when you talk about scalar multiplication of matrices, what is the main idea behind it? It is about multiplying every entry, that is element of a matrix, by the same constant number called a scalar. So the scalar is the main factor here. It is a constant that multiplies a matrix. So in general form, if a matrix A is equal to A, B, C, D, then Ka, where this K is representing the scalar, means that K is multiplying matrix A. And this K will multiply each of the elements or the entries of the matrix. So we are going to end up with Ka, Kb, Kc, and Kd, where this K is a constant known as a scalar. So that is the secret under scalar multiplication. So example is if K is -1, then our matrix A, that is -A, means that we have -1 as our K, and -1 will multiply each of the entries, element of the matrix, for us to have the results of -A, -B, -C, and -D. So if we want to think or brainstorm about an example, let's look at this particular example. We have A equal to a matrix, and what order of matrix is this? We have 1, 2, 3 rows and 1 column, so 3 by 1 column matrix. Then -2A means that -2 is the K, is the scalar, multiplying each of the entries. So to be -2 times 5, -2 times 3, -2 times 2, then our results will be -10, -6, -4. For the next example, we have P as a matrix in the form of 3 by 1 order matrix. So we have 3P, where this 3 is the scalar. It is going to multiply each of the entries. So we are going to have 3 times 2, 3 times 6, 3 times 1, giving us 6, 18, and 3. So in this format too, we also have another example of matrix Q. So we have 12, 13, -3, -9 as 8 entries. So then 1/3. So my K becomes 1/3, and 1/3 multiply each of the entries that we have here. You see here, 1/3 times 12, 1/3 times 13, 1/3 times -9, 1/3 times -3. Then our end results will be 4, 13 on 3, -1, -3. So that is the secret about the scalar multiplication. We multiply the scalar k to each of the entries of the matrix, which is very, very easy and understanding to watch. Now, let's come to the format of combining scalars with matrices. So, given that we have examples of matrices in this form, matrix A, matrix B, matrix C, which are all 2 by 2 matrices. So, we should evaluate 2A minus 3B plus 4C. So what are we going to do? This will be the solution. I'll first find the results when a scalar 2 multiply matrix A. So 2 multiplying matrix A will be in the form 2 times -3, that's -6, 2 times 0, 0, 2 times 7, 14, 2 times -4, -8. Then the result when the scalar 3 multiply B will also give us 6, -3, -21, and 12. Then the results when the scalar 4 multiply matrix C, the result will be 4, 0, -8, -16, because 4 times -4 is -16, 4 times -2 is -8, 4 times 0 is 0, 4 times 1 is 4. Then we have 2A minus 3B plus 4C. We do substitute the answers or the results of the scalar multiplying the matrices at their respective position when it comes to the expression given to us to evaluate. So we have the results here of 2A being substituted here, the results of 3B being substituted here, and the results of 4C being substituted here. Then we perform our normal operation on addition and subtraction of matrices. So the first one, you have -6 minus 6 plus 4, and the answer will give us -8. Then the next one, you have 0 minus -3 plus 0. The answer will give us 3. 14 minus -21, then plus -8. Here is it. Then the answer will give us 19. Then -8 minus 12 plus -16. The answer will give us -36. That is how we combine scalars with matrices to evaluate such expressions. So now let's come to the most confusing aspect of matrix multiplication, which is matrix by matrix multiplication. Here, before we can understand this concept easily without any stress, we need to learn and understand what is meant by dot product concept. So the dot product concept deals with rows multiplying a row multiplying column. And when row multiply a column, the result is scalar. So we have a row multiplying a column. So a row of elements of matrix of the form AB multiplying a column with entries X, Y. So here the red entries to multiply themselves, the green entries to multiply themselves. Then you sum the results together and that will give you a constant value, that is a scalar. So here an example is 2, 3, which is a row multiplying a column of 4, 5, which is a 4, 5 matrix, which is also a column. Under this, the red entries, that is 2 and 4, will multiply themselves. That will be 2 times 4 equal to 8. And the green entries will multiply themselves. That will give us 15. So after having your results, you sum them together. So 8 plus 15 will give us 23. So that is how the dot product multiplication is being done. Let's look at another example that we have here. We have ABC multiplying a column matrix of X, Y, Z. So here A multiply X, B multiply Y, C multiply Z. Then we sum the result together to get a scalar. So at the end of it all, we can have an example of this section 1, 2, 3 multiplying 4, 5, 6. So 1 times 4, then we get the answer 4. 2 times 5, the answer 10. Then 3 times 6, the answer will be 18. Then we sum them and get a scalar or a constant, which is 32. So this is what dot product concept means under matrix to matrix multiplication. So we have the general form, which is going to be expressing or introducing the dot product to deal with matrix multiplication. So here we have a matrix of 2 by 2. We have identified the rows. We have two rows here. We have one row and another row. So row 1 and row 2. Then another 2 by 2 matrix. Here we have identified them based on the column. So column 1 and column 2. If I want to multiply this matrix, I am going to introduce dot product concept. So the dot product concept will be the first row multiplying the first column. So the R1 times C1. Then that will be the first element or the entry. Then you move on. We are not done with the row. It will be the same first row multiplying the second column. That is, the multiplication is in the form of dot product concept. When you are done with the first row, you have to take the second row multiplying the first column. So the second row, first column. Then the second row, second column. So the second row, second column in this format. So dot product concept. So row 1 times column 1, row 1 times column 2, row 2 times column 1, row 2 times column 2. Good. Then our final expression will be a scalar of ax plus by, av plus bz, cx plus dy, then cv plus dz. That is scalar multiplication. The colors will multiply themselves. Then that is the c will multiply x here, color red multiply themselves. Then color green multiply themselves. Then you sum the results together. The same applies to this one, color red, color green. Then you sum the results and get a scalar. So let's look at the condition to multiplying matrix. So we have a very unique condition that you need to follow. Without it, you will get your matrix multiplication wrong. So we have, when we have matrix A, which is in the form of order RA by CA, and we have matrix B in the form of order RB by CB. Matrix multiplication is only possible if CA becomes the same as RB. That is, the column of matrix A becomes the same as the row of matrix B. If that condition is not in process or is not met, then it means that we cannot perform matrix to matrix multiplication. Now, let's see, the RA is the number of rows of matrix A, the CA number of columns of matrix A, the RB number of rows of matrix B, the CB number of columns of matrix B. Then we have to understand this concept. So let's look at it. So RA by CA and RB by CB, the final order of the matrix after you are done with your multiplication and operation, your final answer will be a matrix of order RA by CB. So this and this, good. So here example, order of matrix 2 by 3 multiplying order of matrix 3 by 4. Our final answer will be 2 by 4. Then we have another example here, order of matrix 4 by 3 multiply another order of matrix 3 by 1. Our final answer will be 4 by 1. Then in general, if we have m by n multiplying n by q, then our final answer will be in the form of order m by q. Good. So let's look at this particular diagram here. RA by CA, RB by CB. Then our answer is going to be RA by CB. So let's work an example of this particular section of our studies. Then we have matrix A and B, and we have to find matrix A, B. Then row 1, column, row 1, column. So row 1 will multiply column 1, then the same row 1 will multiply column 2 for us to have the first entries. So 4 times minus 2, that is the dot product multiplication. So the 4 will multiply the minus 2, that's the first to first, then the second to second. So 4 times minus 2 plus minus 2 times minus 2. Then we also have 4 times minus 3, 4 times 3 plus minus 2 times 7. That's the first to first, second to second. Then 1 times minus 2, then 3 times minus 2. Then 1 times 3, then 3 times minus 7. Then our final result will be minus 4, 36, minus 8, minus 18. All these are scaled from the dot product multiplication, row by column. Row 1, column 1. Then the next one is row 1, column 2. The next one is row 2, column 1. The next one is row 2, column 3. Good. So let's see BA. BA using the same process will give us minus 5, 13, minus 15, minus 17. Then it means that look at the answers for AB and BA. Hence, AB is not the same as BA. So matrix multiplication is not commutative. So let's look at another example. We have a 2 by 3 matrix. That is 2 rows, 1, 2, 1, 2, 3. So 2 rows, 3 columns. Then 3 by 1 matrix. So 1, 2, 3 rows, then 1 column. When they multiply, our final results will be in the order 2 by 1. So let's see. When you are done multiplying, so the first will multiply the first, second multiply the second, third will multiply the third. Then the results will be 11. First multiplying first, second, third, third. Then the results will be minus 6. What is the order of this matrix? 1, 2, 2 rows, 1, 1 column. This is amazing and understanding. So matrix multiplication is very much interesting. So let's look at some practical section for us to try our hands on. So we have these particular questions here. Sit down, try your hands on these questions, then send your feedback to me. We have another question here. Try your hands on them, then send the feedback to this particular channel or comment section. Thank you.